So I got this question that I recently did for today. Another one of those videos where I'm testing out new different formats as I'm trying to accumulate my equipment. That's fine. Anyway, so you have a question here. What is the minimum length of string after deleting similar ends? Read the question. It will tell you if it's a non-empty prefix of string s where all the characters in the prefix are equal. Pick a non-empty suffix, etc. The prefix and suffix should not interact at any index that indicates 2 pointers. The characters from prefix and suffix must be the same. Yep. Delete both prefix and suffix, and then they give you these examples. It similar question is basically similar to a palindrome question where it sort of asks you to move your pointers forwards and backwards if they're the same. The difference in this question is that if you have multiple ones and prefix, you wanna essentially you wanna keep moving the left pointer forwards until you reach the point where it's not the same as this, not the same as L and R. They're not the same. So I think the challenge in this question is just to figure out how to move R if you have L that's not the same as the R. And so what you can do to actually solve this question is actually just store what the previous value of L was. And then having known that, then we can simply, instead of comparing R and L directly to each other, what we can do is we can compare R with the current value or the previous value. So that if we know that they're still the same, then we can move this backward. Right. And the same thing goes with the left hand side here. So we are comparing if the left hand side would now be B, right? So this is directly related to B right here. And so if we know that, then we can still move this forward. They're not the same anymore. Therefore, we want to move this. We want to check R. So we move R backwards. It is still the same as the previous value. Same as backwards. Boom. And then once you reach the point where they're no longer the same, that sort of is where we can end the whole while loop right there. It's a while loop because so why is it a while loop, not a for loop? Because it is based on a conditional iteration. And so I think we can just easily solve this from using this point. You're gonna need a left pointer and a right pointer. You're gonna need to find the length. The length is the same as in other questions, so it will simply be whatever R is minus L plus 1. Remember, it's plus 1 because it's 0 index. Because you take into account 0, 1, 2, and then 3. And then, so what is the total length? Total length, we can simply, probably just, total length, we need the minimum, right? What is the minimum length? I'll leave it as for now. What happens? So we said while they don't, if they don't intersect, and L, it's the same as the R. You want to store your previous value based on the initial value of L. And then if, let's say, while L is less than R, so essentially while they're not intersecting, we want to move this backward based on the previous value. Because we know that if they're not the same, right, we are comparing R with the previous value where L is already running at. So forward, same thing comes here. You can say, get this up. Let's say if this is, let's say if this is L and R. Once you get to this point, we need to make sure that they don't intersect for one, and also the previous value L, the R is the same as the previous value, but also we want to make sure that let's say we get to this point. A good example. Because when you get to this point, right? At this point, you can remove them directly, but we need to make sure. It's like also at this point, then uh, the left hand side would be already here at this point. So then we need to reassure that R can now safely move downwards by essentially saying if R is still less than if R is still greater than L, and I think this condition will still work. I think I want -1. And then basically, what is the total? Total is gonna just be the minimum of total and the length of R minus F. And essentially return that in. And this should give you a log of n solution based on the two-pointer solution. And I think that's two-pointer solution. It's a two-pointer solution. I think it's a log of n. I'm right. I think it should be a log of n or just n. Yeah, n. Yeah. So I thought so it's a big of n solution with no space that we need. So if we press this, yeah. Turns out we don't need this. Anything else? Oh, all right. So yeah. So when you get to this point, right? So R and L are in the same place. I think if they're just there we go, guys. Big of n solution. Like a subscribe. There you go.